All righty, let's get started. The notes today, hopefully, it is my plan. Hopefully we get through them faster than the notes last class. I know that we kind of used the whole period last time. But that is not my hope today. Hope today is to get done a little faster. As a reminder, we do have a quiz next class. So I would like to formally invite everybody to put their phones and things away. Take ownership of your learning. Also, I'm reading an interesting book. And the book says that by and large, very few people, and there's a name for it, I can't think of it, have the ability to, and this is it's not like a fiction book. It's a book about the advantages of being dyslexic. But it says very few people have the ability to, because we hear all kinds of noises at the same time, but very few people have the ability to tune out distractions and process the important stuff and only focus on the important stuff. That means that when you guys also have in your music and stuff, for some people, it can be a therapeutic thing, having music or whatever, but by and large, most of us have a really hard time listening to me and listening to something else or watching a movie at the same time while you're trying to take notes. So maybe we need to pause whatever it is that we're listening to so that we can fully focus on me and my voice. First thing that we're going to do is talk about multiplying radicals. The title of today, multiply. It's multiplying radicals. I just couldn't fit it all on the line. Multiplying radicals and things with rational exponents. And then we're going to solve equations with radicals and rational exponents. So to multiply radicals, it's really pretty easy. There's just two parts. We will multiply the stuff in front. The numbers in front of the radical, like the 6 and the 4, what would we call those? Coefficients. So that's the number that goes, or the word that goes in the blank. So we're going to multiply the numbers in front of the radical. And for some of you, it may be helpful that since we know that we're multiplying these things together, you can kind of give yourself a little reminder that, oh yeah, these things go together and we will multiply them together. The other part of multiplying radicals is that we will multiply the stuff inside the radical. This was a new math word that we learned last time. What's the stuff inside of a radical called? Don't know? Dig out your notes. You also need that chart that we made last time. I told you that that chart is going to be the most useful thing that you have. We're going to use it today too. Don't lose that chart. You might even get to use it on your quiz. So don't lose it when you don't know how to use it. So get it out, write your name on it just in case you leave it. So looking back at our notes from last class, what is the stuff that's underneath the radical? What is that called? Say it again. The stuff underneath the radical? The stuff underneath. Say it. Say it proudly. Oh. It's a weird name, right? Radicand. You might be saying it right. I might be saying it right. It's kind of a weird name, weird word. Radicand. So that's that stuff underneath the radical. That stuff goes together too. So the inside goes together and the outside goes together when we multiply. So that's what we're going to do first. We're going to rewrite it and we're going to multiply the outside with the outside, the inside with the inside. So looking at the outside, I have 6 times 4. So 6 times 4 is 24. Then I have radicals. So since the two radicals are going to go together, I'm going to make a big radical. You have to turn it off. It's so loud. So then I'm going to look at the stuff underneath the radical. Numbers go with numbers. The variables go with variables. So as I'm multiplying this, the inside stuff, I'm going to multiply the 8 times 2, and that'll get me a number. And then I'm going to look at the x's. I have 3 and 1, so that'll make 4. And then I have 5y. I put it together, I'll have. Good job. So that's what I'm going to do. I'm going to rewrite everything as I multiply it together. So 8 times 2 is 16. And then I have 3 and 1, so that's 4. 5 and 3 is 8. Go with me so far? All right, now we're going to simplify. Simplifying is what we did last class, over and over again. To simplify, we rewrite stuff. So you want to rewrite stuff so that it matches the index. Remember, the index is what kind of root you have. For this one, there isn't a number, so what is it? So 2. Good job. So we want to write things as a square exponent, or to the second power. So using your handy dandy chart, that column is the only one that matters to us. So looking down that column is 16, and that column, is it a perfect square? Yay! So I'm going to rewrite that. Uh, 16 is what to the second power? All right, so x to the 4th power. Remember, if those exponents divide evenly by that index, then we can rewrite it with parentheses. So for this one, the index is a 2. Can 2 go evenly into 4? Yes, 2 times, right? So I can rewrite the x. And since I can rewrite it and 2 goes in there evenly, 2's on the outside, 2 times of what gives me 4? 2 times 2. So inside I put a 2. And then for the y's, is 8 divisible by 2? Yes, so we will rewrite that one the same. So that one as well, we will rewrite it with an exponent of 2, because 2 is what will cancel or reduce. And so we put the 2 on the outside. 2 times what gives me 8? 4. So I put the 4 on the inside. As I go to rewrite it, what I'm looking for is anything that is to the second power, because those are going to reduce. It looks like that 4 is going to reduce. That's going to reduce. That's going to be reduce. Am I going to have anything left underneath the square root? No, that's okay. I just eliminated the square root. Now I need to keep in mind that as I do this, any numbers that come out into the front, they will multiply. So this will be 24 times 4. And then x squared goes out front and y to the 4th goes out front. But I can evaluate that. I just wanted to write it out step by step so that you see what I'm doing. What is 24 times 4? Thanks. Multiplying radicals. Okay, well, let's do it again. The next one, same steps. I'm going to multiply the stuff out front and then the stuff inside. So I would like for you guys to try and do that on your paper. You try and just that first step where you're just multiplying everything out, and then we'll simplify together. Try that first step where we multiply the front times the front, the inside times the inside. That first step, do you agree? Brooklyn, you're erasing. Why? Okay, okay. I'm processing what you said, the 4 and 4.
No.
3 and 2.
No, the other one. The one next.
This?
Yeah.
Guess what? Those aren't exponents. Those are the index for your radical. I'm glad you asked because you're probably not the only one that wondered that. So remember that this is kind of like the chair. If there's nothing in the chair, it's a 2. But if there is a value there, it is representing what type of root that you have. So it is there for me. It is the 4th root. Good question. Was that what all you were asking? Was that number? Okay, yes. Okay, what about this? Any other questions? Anybody else make a mistake but you were able to fix it and you understand why? Okay, well, let's simplify. This is the stuff we did last class. So I'm going to go through and what exponent will cancel? No, I'm sorry. I didn't say that clearly. What do we need exponents to be so that they can cancel? 4 has to match the index. We need exponents to match the index. So if the index is 4, we want things to the 4th power. And you're right. The y will cancel because it's already the 4th power. That's nice. So let's go through. I'm not doing anything with the 6 out front. And that index, the little number out front, it's not optional. It has to be written there every single time. So 16, the column, the only column that we care about is looking down the x to the 4th power. So down that 4th power column is 16 there. Okay, so then that means 16 can be rewritten as something to the 4th power. What is it? Okay, do we agree that it's 2 to the 4th power? Okay, the rest of us just misspoke. 2 to the 4th power, and then 8 is 8 divisible by the index. So is 8 divisible by 4? Yes. 8 divides by 4, right? Sorry. Yes. 8 divides by 4. Do you understand, Adeline? Okay. Yeah. So if it is divisible, y'all made me concerned that I said something wrong. It is divisible, so I can put the 4 on the outside because what I want is things to the 4th power. So 4 times what gives me 8? 2, so the 2 goes on the inside. And then the y to the 4th power, it's already to the 4th power, so ta-da. I'm going to go through anything to the 4th power, matches the index, so it cancels or reduces. Am I going to have anything left underneath the radical? Nope. Could I have something left under the radical? Like if it was a different type of problem? Sure, I could. I just don't. All right, so out in the front, I end up with 6 times 2 or 12. and I have an x squared and a y. How do we feel so far? The notes, good. Yay. I even got a full thumbs up. So on your assignment, this is the first 6 questions on the assignment. Now, I do want to point out that it seems like a lot of work, sort of like here I had 1, 2, and this one you don't necessarily have to do if you know that this multiplies by this, but it's basically 3 lines of work for each one of those problems. It's not difficult, but you are going to have work shown for all of them. You're in for a real treat because the bottom 6 questions on your homework are way easier. So don't get started on your homework because I don't want you to miss these things that are super easy. For these, it says that if we want to multiply bases that have rational exponents, I want to remind you that rational is from the word ratio, and a ratio is just a fraction. It relates to things. So do you see how all of these have fraction exponents? Those are just rational exponents. So multiplying rational exponents, you must remember the product rule for exponents. Now, I would bet money that nobody could recite that to me, but that's okay because we're going to review it together. For this one, we are multiplying like bases, like because they're both x. So I'm going to show you what I mean here. Like. And when you look at the 4 examples, see how they're both x, both w, both y, both x. You can't multiply them together if they're not the same. So if it was an x and a y, those don't combine. Only things that are the same base. You got to have the same base. When you multiply like bases, 2 things that are the same, what are you doing to the exponents? I show you right here. What are you doing? Adding them. So it says that if I have something to 1 power and I'm multiplying it by the same thing to a different power, it could be the same power as well. I add the exponents together. So you add exponents. When you multiply, you add exponents. Does anybody remember what you do when you divide? Subtract. Yes, we're not actually going to do that, but if it was a bonus question on a quiz or something like that, then it would be good to know. So we're going to add exponents. Well, here's the thing. The exponents for these are fractions. So if you're adding fractions, what do you have to be able to add fractions? Okay, we don't remember. So we're going to start and we'll fill in these blanks and we'll figure it out when we get there. Since rational exponents are fractions, you must have blank denominators before you can blank them. You must have what kind of denominators? Well, and it tells you here what we're doing. So do we know this blank? We're adding them. Okay, before we can add fractions, we have to have blank denominators. Exactly right. They have to be similar. They have to be the same. They have to be common. So let's write down all those words. They have to be like denominators. They have to be the same. all those work. They have to be the same. You cannot add fractions unless you have the same denominator. When they are the same denominator, fine. You just add them together. So let's start. It says simplify. We are multiplying bases. So what do we do with the exponents? Them. So we have x to the 2/7 plus 4/7. When you have the same denominator in the answer, you still have the same denominator. It doesn't change. It does not become all of a sudden 14 or some crazy other math thing you think you should do. It stays the same. Yes. We do all this work to make sure that the bottom is the same. Don't change it. So it will be a denominator of 7. And so we will add the top. 4 and 2 is 6. Bam, done. For B, do I have the same denominator? Yes. So guess what? My answer is going to have a denominator of what? Yay. Okay, so now all we have to do is add the top. Does that reduce? Let's reduce it. We can reduce. So 10/4, they're both divisible by 2. So I can divide by 2 and divide by 2. So I get 5/2. Good job. C, is the denominator the same? That's okay. I can make 2 turn into 4. How? What would I multiply by? 2. So the thing is that I can't just multiply by 2 on the bottom. I have to multiply by 2 on the top. Technically, anything over itself is 1. So you can multiply anything you want by 1. You're not really changing it. So this turns into y, and I still have 3/4. So that's 2 times 1 on the top, which will be 2/4 now. When you multiply, the top multiplies and the bottom multiplies. So when you multiply, both numerator and denominator will actually change. All right, so now I have like denominators. It is a 4, so my answer is going to have what denominator? 4. On the top, I'm adding, so it's 3 plus 2. You think that you can do D all on your own? Let's try it. Let's talk about it. Okay, we probably all tried it. These are super fast. For D, there is a common denominator. It is 5. So my answer is going to have denominator of 5. And then all I do is add the top. So 1 and 4 makes 5. Okay. What's anything over itself? Very good. What's anything to the first power? How do you feel about the front page? Good. The back, on to the back. The back says solving equations with radicals or rational exponents is the same as solving any other equation. To solve equations, we use things to help us. Okay, what undoes things? And there's words under here that you can maybe use. There's something that helps you undo stuff. What can help you undo operations? The inverse. So we can use inverses. So you know this, to cross the equal sign, if you're adding, you got to subtract. If you're multiplying, you've got to divide. We use inverses to undo operations. Y'all know this. Let's complete this inverse operation chart. So you have 3 blanks to fill in. Let's see if you can jot down what is the inverse operation that goes with subtract or divide or squaring something. See if you can fill in those blanks while I take attendance. Andres is not here. Dariana. Okay, let's see how we did. What is the inverse operation for subtract? Very good. So if we're subtracting on one side, we can add to the other. What is the inverse operation for divide? What if you want to undo something squared? Yes, square root. So if you have something squared, we can square root. And so all these work both ways. The last one, you actually undo either one of these the same way. The reason is because last class, remember how we learned that everything to a fraction exponent or a rational exponent, it can be rewritten as a radical, right? It's part of your homework. You can rewrite a root as a rational exponent or a rational exponent as a root because they're the same. It's just a different way to write something. So whether we have something to the nth root or we have some rational exponent with the nth denominator, which corresponds with the index, either one of these types of things, you undo it by raising all of it or both sides to the n power. So if you have the nth root, you raise it to the nth power, whatever that number of the index is. Or if you have a rational exponent, you look at the denominator, whatever that denominator is, you raise it to that nth power. Well, let's do some practice problems so you can see all this fun stuff in action. For the next one, part A. Well, there's nothing else over there. And our goal is to get x by itself. So we want to isolate the variable. So our goal is to get x by itself, but I can't even do anything with the addition subtraction until I get rid of this grouping. So to undo a square root, what do? Square. And so remember, we got to do it to both sides. So I need to square this side and square this side. When I do that, the square root will cancel. And what's 3 times 3? This just turned into a simple one-step equation. I have one last step left. What is it? Very good. I subtract 2. 9 minus 2. This says, don't forget to check your answer by substituting it back in. Sometimes you get an answer, but it doesn't actually work. So if an answer doesn't work, it would be because when you plug it back in, you end up with a negative underneath the radical, and we can't take the square root of a negative number. More often than not, it's not what you're dealing with. Sometimes you can even mentally check things back in there. So if my answer is 7 and I plug it in, what's 7 plus 2? 9. What is the square root of 9? 3. So that one works. So I just checked it. It's good. So again, sometimes you can mentally check them if there's not a whole lot of stuff going on. The next one. All right. That one has a fraction. We don't like that. That's okay. You'll see that they're just fine. Before we can even deal with y or the rational exponent, we need to get rid of that. So how do I get rid of minus 7? I need to add 7. All right. So what I would like to do now, I have to look at my chart. If I have something to a rational exponent, I undo it the same way I do a root. So I have to raise everything to the second power. It has to match that denominator. When it matches the denominator, those cancel. Because it's like divided by 2 and then multiply by 2. Those undo each other. So I end up with y to the first power, which is just y. And then 7 squared. What's 7 squared? 49. If you were to check that back in there, we should remember that this right here is the same thing as y squared, because that denominator can be written out in front and it becomes your index. So if I think about it like this and we say that y is 49, what's the square root of 49? 7. What is 7 minus 7? 0. It works. We are solving some really big kid equations. How are y'all doing so far? All we're going to do is add some flair. For C, okay, we just put some more stuff in there. We're going to work it the same way. What do we have to take care of first? Okay, so then let's give ourselves a note, because that is not what we take care of first. You have to first isolate the square root or something to some rational exponent. So if we look at C, do I have the square root or the fourth root all by itself yet? No. So I need to get rid of this first. So I need to get rid of minus 3 by adding it. Three plus 1 is 4. Now then, have I isolated the radical? Yes. So now to get rid of it, I can do what? If you don't know, look at your chart. How do we undo a radical? We have to raise it all to that index power. So this one is, what's the index for that root? 4. So these have to match for them to cancel. What is 4 to the 4th power? Look at your chart. Nope. Very good. So the chart is very helpful, right? Have y'all used it a lot? I think it's a helpful chart. All right. So now it's a two-step equation here, friends. What do I do? Very good. Subtract 7. What is 256 minus 7? 249. My last step, what do I do? That's a big number. So I've got 249 divided by 3. $83. Okay, if we plugged it back in, what is 3 times 83? 249, okay. So 249 plus 7, 256. Down the x to the 4th power column, do you find 256? Okay, it's what to the 4th power? 4, okay, so that reduces to just 4. What is 4 minus 3? 1. Yay, our answer is correct. My last problem. Do I have the stuff raised to a rational exponent? Do I have it all by itself? Do I have just parentheses, rational exponent all by itself? No, because I have this random 2 over here. I need to get rid of it. I have to get everything else away first. So I'm multiplying by 2. So what will I do? Y'all are good. So I'm left with 6x minus 4, all of that to the ugly 1/3 power. 4 divided by 2 is 2. Now I have the rational exponent all by itself. So what do I do? Yeah, I raise it to whatever power I need. So which power am I going to raise this to? The 3rd power to cancel that out. And I have to do the same to the other side. So I get 6x minus 4 and is equal to 2 times 2 times 2. 8. All right, simple 2-step equation from here. I want you to finish it on your paper. I'm going to finish it on the board. I believe in my heart that you guys can get this correct. Did you get the same thing? Good. Okay. If we were going to check that, if I plugged it back in, what's 6 times 2? 12. What's 12 minus 4? 8. Okay. Something to the 1/3 power. So this is 2. And then we've got something to the 1/3 power. The 1/3 power is the same thing as the cube root. And it's the cube root of 8. So down that x to the 3rd power, do you find 8? X to the 3rd power, is it in that column? Do you find 8? Yes, what is it? Okay, so that is 2. What's 2 times 2? Yes, we got it. It's good. It works. Good job. We are done for today. And there's actually one